We have the function f of x equals 2x squared plus 4x plus 3. And I am supposed to graph this. I do see that it is a quadratic equation because of the x squared. So it is a parabola. And the coefficient of the x squared term is 2. It's positive. So I know that this parabola will open up. But I am not able to see the vertex of this parabola easily. So in order to find the vertex, I could complete the square, or I could simply find the x of my vertex by plugging in negative b over 2a. Now remember, our coefficient with the x squared term, that is our a. Our b is the coefficient with the x to the first, and our c is the constant. So x of my vertex will equal negative b, which happens to be 4, over 2 times a, which happens to be 2. So that would be negative 4 over 4, which is negative 1. So I know that the x of my vertex is negative 1. But remember, the vertex is a point. I do not only need an x, I need y also. Well, I will take my x equals negative 1, plug it into my function in order to find y. So our function, remember, f of x is just a fancy way to say y. Y is equal to 2 x squared. So my x is negative 1. I will square it, plus 4 times x. So that will be 4 times negative 1 plus 3. Remember to do your exponents first. So that would be negative 1 squared, which is a positive 1. 4 times negative 1 is a negative 4. So 2 times 1 is 2. 2 and a negative 4 is a negative 2. Plus 3, that is a positive 1. So my y is equal to positive 1. Okay, now I need to find my x-intercept. In order to find your x-intercept, you let y equal 0. And we do have a quadratic equation. And how do we solve these? We could factor them. We could complete the square and use a square root property. Or we could use the quadratic formula. So let's use the quadratic formula for this one. Remember, a is 2, b is 4, and c is 3. So we will have negative 4 plus or minus the square root. B squared, that'd be 4 squared, which would be 16, minus 4 times 2 times 3 will be 24. All of that divided by 2a, so 2 times 2 is 4. So I will get negative 4 plus or minus, look at this, it's the square root of negative 8. And yes, all of that is divided by 4, but I have the square root of a negative number. This is not a real answer. So as for an x-intercept, there are no x-intercepts. Okay, for the y-intercept, in order to find the y-intercept, we will plug in 0 for x. So it'll be 2 times 0 squared plus 4 times 0 plus 3. So y will simply equal 3. So that will be the point when x is 0, y is 3. Okay, so we know the vertex is at negative 1, positive 1. We know that it opens up. And we don't have any x-intercepts. The y-intercept is 0, 3. And this is just a sketch. So it would probably be good for me to pick another point just to help guide my parabola. But I know that negative 1, 1 is the vertex. And I know it opens up. And I know it goes to the y-intercept at 3. So this is a sketch of my parabola. But I could pick any x I wanted to, plug it into my equation, my function, and find another point to get a better parabola. So let's work on our domain and range. The domain which x are included in this graph? Well, this parabola is going to go on and on and on to the left and to the right. So my domain is negative infinity to positive infinity. But the range, if you notice, we don't have our function down here at any of these range or these y's, -5, -4. We do not come in contact with our graph until our y's or our range is 1. But then as we go up to infinity, it is part of our graph. So our range will start at 1 and it includes 1 and it will go to infinity. And when we did the algebra and got the x-intercepts and got an imaginary number, I should have guessed that it will never cross the x-axis. Okay, let's graph another one. Once again, I do know that this is a parabola. We have the function 2x squared plus x minus 6. I do know that my parabola opens up, but I can't readily see the vertex. So I am going to have to use a formula. X is equal to negative b over 2a, which in this case will equal negative. B is the coefficient with the x, so that would be 1, over 2 times a, that would be 2 times 2, so the x is negative 1/4. Now, I need the y for my vertex. I have the x, I need the y. So when the x is negative 1/4, I'm going to plug that in and find my y. Let's do that now. So wherever I had x, I plugged in negative 1/4. We are looking for our y. Make sure you do exponents first. Negative 1/4 squared. 1 times 1 is 1. And 4 times 4 is 16. And it will be a positive. And they have minus 1/4 minus 6. When you multiply fractions, you just multiply them straight across. 2 times 1, 6. Now, I just put a positive there, so you know that's a positive. It may be better for us to erase that so to make sure you know that we are multiplying. Okay, let's do some simplifying. When I simplify fractions, I'm multiplying here. Just multiply straight across. That would be 2 over 16, which is 1/8. So I have 1/8 minus 1/4 minus 6. You can get a common denominator now or use your calculator. My common denominator would be 8, so that would be 1/8 minus, this would be 2/8. That's the same thing as 1/4 minus, and 6 times 8 is 48. So 48 divided by 8 is 6. So that's the same thing as 6. I have 1 minus 2, which is negative 1, minus 48. So that will be negative 49/8. Since I'm graphing this, it may be best to change this to a mixed number. So 8, we're going to 49. That'd be 6 times with 1 left over. Negative 6 and 1/8 is my y of my vertex. Okay, so we have our vertex, and we know that this graph opens up, this parabola, and I need my x-intercept. Well, once again, I am going to use the quadratic formula. So it would be negative b plus or minus the square root of b squared, that'd be 1 squared, which is 1, minus 4 times a times c, which would be a negative 48. All of that over 2a. 2 times 2 is 4. Let's simplify. These are my x-intercepts. I'll have negative 1 plus or minus a square root of 49. All of that over 4. Oh, and the square root of 49 turns out nicely. That would be 7. A little bit more simplifying to do. Negative 1 plus 7 will be 6/4. That will reduce to 3/2. So that is one of my x-intercepts. The other x-intercept will be negative 1 minus 7, which is negative 8 over 4, which will be negative 2. So our x-intercepts are 1.5 and negative 2. And remember, when we are looking for our x-intercepts, we have y equal to 0. Now let's find the y-intercept. So in order to find the y-intercept, I will let x equal 0. So that's going to be 2 times 0 squared plus 0 minus 6. So y will be negative 6. So when x was 0, y was negative 6. Now let's graph this and find the domain and range. My vertex is at negative 1/4, just a little bit to the left, and negative 6 1/8. So negative 6 is down there. I'm going to go a little bit farther. My x-intercept, I have one at 1.5, 0, and at negative 2, 0. I know it crosses the y-intercept at negative 6, so that would be right above my point. It crosses right after my vertex. Okay, so now we can draw our parabola. Okay, it's not a pretty parabola. This parabola opens up, so it has a minimum value down here at the vertex. What's the lowest value it has? Negative 6 1/8 is as low as my parabola goes. And where does this happen? It happens when x is negative 1/4. The domain, negative infinity to positive infinity. And the range, of course, we talked about the graph starting down here. It would be negative 6 1/8, and it does go to infinity. Okay, for the last problem, we are supposed to determine, without graphing, whether the function has a minimum or a maximum. We are supposed to find the min or max and determine where it occurs, and we should identify the function's domain and range. And we have to do all this without graphing. Well, my function f of x equals negative 3x squared plus 6x minus 13. I do know that it is a parabola because of the x squared, and I also know that it opens down because I have a negative coefficient for my x squared. Well, since this opens down, I know that I will have a maximum value. And remember, the max to the min occurs at the vertex. So I want to know, what is this vertex? Well, in order to find the vertex, when your function is in this form, you will let x equal negative b over 2a. So that will equal negative b is 6 over 2 times a. A is a negative 3. So we will get negative 6 divided by negative 6, which is positive 1. My x of my vertex is 1. Now in order to find y, I needed to take 1, plug it in for x, and do a little math. So f of x, that's just y, is equal to negative 3, and our x is 1. We will square it. Plus 6 times x, which is 1, minus 13. We will have negative 3 times 1 squared is just 1. So negative 3 times 1 is negative 3. 6 times 1 is 6, minus 13, and I will get negative 10. So the y of my vertex is negative 10. I have determined that this parabola opens down, which means that it will have a maximum. The maximum value that it has is negative 10. It's actually very low. That's as high as my y is going to get. And where does this occur? It occurs when x is 1. So if I wanted to jot this down, so we said our vertex was at positive 1, negative 10, and we knew that it opened down. So I knew that this was my maximum value. So how high did it get? Negative 10. And where did that occur? When x was 1. So for the domain, well, this parabola will still go on and on and on to the left and the right. The domain will be negative infinity to positive infinity. The range will be negative infinity. And if you notice, my y's, yes, they are graphed down here. And they go up, 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 but they stop at negative 10. I don't have any of my range graphed above negative 10. So my range will be from negative infinity, and it's going to go up to negative 10, but then it will stop. That is our maximum value. So remember, if I'm looking for the maximum or minimum on a parabola, you're really just looking for the vertex. And if the parabola opens down, such as this one, it's a maximum value, it's a high point. If it opens up, then you're going to have a low point on your graph, which will be the minimum.